Hello. So here we're going to discuss chapter 10, section 4, area and polar region. So we have a case where we are given a polar curve, which is given as r equals f of theta, and we are given angle theta, which is theta equals beta, and this angle is alpha, and the region between them is what we call polar region. So the question is, what is the area of this polar region? So we say this region, this polar region, is bounded by r equals f of theta, which is this polar curve, theta equals alpha, and then theta equals beta. So and then the assumption is alpha is less than beta, clearly. So again, the question is to find the area of the polar region. So what is the area of this region? So we can explain all those Riemann sum, but the bottom line is to find the area of the polar region, you will have to integrate from alpha to beta. You're going to integrate 1 over 2 times f of theta squared d theta. F of theta is r, so r equals f of theta. So if you want this version of the formula, you write 1 over 2 times r squared. That's what you're going to integrate from alpha to beta. So here is an integral that doesn't have derivative in it. So to find the area of a polar region, you have to integrate from alpha to beta 1/2 times f of theta squared. For example, they ask you to find the area of the region in a plane enclosed by the cardioid r equals 2 times quantity 1 plus cosine theta, where theta is between 0 and 2 pi. So when you graph this curve, this polar curve, you get from 0 to 2 pi. So you're going to get this polar region. So to find the area of this polar region, we put down the formula. We know because of this interval of theta, we know alpha is 0, beta is 2 pi. And since we're going to square r, so we're going to square 2 times quantity 1 plus cosine theta, and then times 1/2. So we get our integral. Here, if you square 2, you get 4. Then you bring 4 outside, divide by it. You bring also this 1/2 outside, you get 4 over 2, which is 2. Then you're going to, before you integrate, you're going to FOIL 1 plus cosine, quantity 1 plus cosine theta squared. When you FOIL it out, you get 1 plus 2 cosine theta plus cosine squared theta. And so on this stage, we know how to integrate 1. We know how to integrate 2 cosine theta, but to integrate 2 cosine squared theta, we have to go back to using the double angle formula. So cosine squared theta is 1 plus cosine theta over 2. We can rewrite as 1 over 2 times 1 over 2 plus cosine 2 theta over 2. So we do the substitution. We get this. We add like terms. 1/2 plus 1 give us 3/2. So at this stage, we can integrate all the terms. When you integrate a 3 over 2, you get a 3 over 2 theta. When you integrate 2 cosine theta, you get a 2 sine theta. When you integrate 2 cosine, when you integrate cosine 2 theta over 2, you get 1/2 times sine of 2 theta over 2. That 2, you bring it down, because this 2 came from 4 over 2. And then you evaluate at 0 and 2 pi. So when you evaluate this at 2 pi, you get 2 pi, and then minus, you evaluate at 0, get 0. Plug in 2 pi for theta here, you get sine of 2 pi, and then minus sine of 0, and then do the same thing. 2 pi give you 4 pi, and then minus 0. But sine of 0, sine of 4 pi, sine of 2 pi all give you 0. So all of this is 0. Contribution is here. So you simplify 2, you get the 3 pi times 2 give you 6 pi. So that's one of them. The last one is find the area inside the cardioid. R equals 4 plus 3 cosine theta, and then theta is between 0 and 2 pi. So if you graph it, it looks like that. And again, the same thing. You have a half, you square R, okay, and when you expand it, FOIL it out, you get 16 plus 2 times 4 times 3 cosine theta plus 9 cosine square theta. You end up with 9 cosine square theta here, which you cannot integrate until you change it to double angle formula. When you plug in this, you multiply this by 9, you get this. Add like terms, 9 over 2 plus 16 give you 41 over 2. And I have 24 cosine theta plus 9 over 2 cosine 2 theta. You integrate the first one, you get 41 over 2 theta. And you integrate cosine, you get sine. You integrate cosine 2 theta, you get sine 2 theta over 2, and then times 9 over 2. You evaluate each term at 2 pi and 0. Of course, you keep bringing a half down. So you got 2 pi minus 0, which is 2 pi, times 41 over 2. So that give, but everything here is 0. Sine of 2 pi, sine of 0, sine of 4 pi, all of those give you 0. The contribution comes only from here. Simplify 2, you get 41 pi, and then divide by 2, which gives you the answer. 41 pi over 2 is the area.